Hi, I'm James Carone, Decision Support Meteorologist with Atmospheric G2, and I'll be presenting on the infamous polar vortex, what it is, how it forms, and does it actually guarantee extreme cold outbreaks in the wintertime? So starting off, polar vortex is an atmospheric circulation in both the troposphere and stratosphere. Let's assess the stratospheric polar vortex first. The polar stratosphere loses sunlight and cools in fall and winter while creating a temperature gradient. A temperature gradient forms strong westerly winds in the stratosphere, sometimes called the polar night jet, surrounding the North Pole at 10 to 30 miles above the surface. Winds flow in a concentric circle around the pole and encloses a large pool of extremely cold air. Westerly wind can weaken or reverse course, breaking down the polar vortex. One final note on the stratospheric polar vortex is that it only appears during the winter. Let's discuss the tropospheric polar vortex next. The tropospheric polar vortex is a band of strong westerly winds in the troposphere surrounding mid-latitudes at 5 to 9 miles above the surface. Located at the edge of the tropospheric polar vortex is the polar jet stream. Quick note that the polar jet stream is simply a line of fast-flowing air separating colder air masses to the north and warmer air masses to the south. The tropospheric polar vortex can expand with the jet stream moving southward or contract with the jet stream moving northward. One final note on the tropospheric polar vortex is that it appears year-round, unlike the stratospheric polar vortex, which only appears in the wintertime. Next, let's discuss the troposphere and stratosphere interaction, also known as coupling. Planetary waves, also known as Rossby waves, naturally occur due to the Earth's rotation. Atmospheric Rossby waves form primarily as a result of the Earth's geography. With a larger landmass in the northern hemisphere compared to the southern hemisphere, Rossby waves are primarily a northern hemisphere-focused phenomenon. The only known exception was September 2002, with a stratospheric warming event in the southern hemisphere. Important note, Rossby waves help transfer heat from the tropics toward the poles and cold air from the poles toward the tropics in an attempt to balance the atmosphere. Continuing on with the topic of Rossby waves, let's discuss its relationship with a stable versus unstable polar vortex. Atmospheric Rossby waves can sometimes amplify into the stratosphere and break. Breaking waves exert drag on the polar night jet and weaken it like a spinning top that begins to slow down and wobble. If waves are strong enough, they can decelerate westerly flow or cause reversal to easterly flow, disrupting the stratospheric polar vortex. The stratospheric polar vortex is displaced from its normal location over the pole or is split apart into two vortices. Winds within the weakened jet slow down and turn towards the center of the polar vortex. As air converges at the center of the polar vortex, it descends. Cold air descends quickly in the polar vortex, and this causes the temperature in the stratosphere to rise quickly, as much as 50 degrees Celsius or 90 degrees Fahrenheit, over a few days, hence the term sudden stratospheric warming. As air descends over the pole, atmospheric mass builds and pushes cold air at the Arctic surface southward, while warm air is drawn up to the Arctic. Important note, a quote-unquote strong, or in other words, stable polar vortex generally keeps cold air bottled up in the Arctic and creates a warmer pattern for the mid-latitudes, while a weak or unstable polar vortex allows cold air to spill from the Arctic into the mid-latitudes, creating a colder pattern. Let's look at an example from the winter of 2017-2018. The graph shows stratospheric temperature, purple line, and west to east winds, the gray line, from July 2017 to March 2018. As they do in most years, the winds creating the northern hemispheric polar vortex formed in late August and strengthened through January. As the winds strengthened, the temperatures dropped. When the winds dipped below 0 meters per second on February 12th, a sudden stratospheric warming occurred. Important note, such a series of events regarding stratospheric warming and the polar vortex do not guarantee cold for North America. Cold spilling out the Arctic can be displaced towards Europe or Asia depending on the pattern. This example from late winter 2018 produced what's known as the Beast from the East, an extreme cold air outbreak from February 24th to March 4th, 2018, that dropped the UK's overnight lows down to minus 20 degrees Celsius, which converts to minus 4 degrees Fahrenheit. Lastly, here's another good example from NASA's Atmospheric Infrared Sounder instrument capturing a polar vortex moving from central Canada into the United States Midwest region from January 20th, 2019 through January 29th, 2019. That concludes my discussion. Thanks for your time today, and please feel free to reach out to us here at Atmospheric G2 for all of your weather needs.